Hi, this is Bruce from Safiery, and we're here showing the real data for a street vending ice cream machine running an Aerowhip machine over a day on this last weekend on a full Saturday, and to show potential buyers the longevity of using Scotty and our battery system. So this street vending scenario started at around 11 o'clock, 11:47, and went all the way through until after 7 o'clock at night. So it's pretty close to 8 hours here. And during that period of time, the battery state of charge here went from 99%, it went down to 32%. So there was still a little bit more in reserve here. Now, this is the actual power being used, AC output power. So you can see here that this was turned on before they went off for the run, so that the machine was brought up to speed and temperature, and then off they went. Typically, during the run here, it's 2.5 kilowatts there, about 3 kilowatts there, very close. And so these are machines running around about the 3 kilowatt mark, right up touching the 3 kilowatt mark here, and running the whole time. There was only one spot in the middle here where it dipped down to rest there at about 540 watts. But what we find is these machines are running, drawing 3 kilowatts continuously for the whole 8 hours. Now, this chart here, this DC system here, is the power coming out of the alternator, which is our Scotty. Now, the vehicle here is just idling for most of the time. You can see here about 1.5 kilowatts at idle. Nothing during this period of time. It was stationary. The engine wasn't running at all. And then we're back to idling again. Now, at full speed, it'll do, you see 1800 watts. We've tuned this system to give the best possible power at idle. And so even when it's driving, it is doing probably about 2 kilowatts. These are 15-minute averages here. But during this period of time, the energy is coming in from the alternator, quite a lot of power. So that white space you see in there is all the energy coming in. Now, we've equipped this machine with an 8 kilowatt or an 8000 VA inverter charger, but we still had 3 overload warnings. So although you're seeing 3 kilowatts, we still had 3 overload warnings, but it didn't stop the system at all. That's the actual battery voltage. So our native battery voltage here is 52 volts, came down pretty steady across here. That's pretty textbook for this amount of load. And the battery temperature here, which is a sign of how hard the battery's working, didn't go over 38, and the battery's good to go up to 55. So it went from a start of 24, it was a warm day on Saturday, and went up to 38 degrees, and then it was pretty steady in this last period of time and coming up into the evening and late afternoon. This is just showing the input power. So the input power during that period of time, there was absolutely no AC input, no GENSET whatsoever during that period of time. And this is when it came back in, it was plugged into charge. So there it's taking the full charge at home. This last one here is a technical indication of the amount of current that can come out based on the CAN bus messaging from the battery, which is 125 amps, 6 kilowatts, continuous this is, and it didn't even reach that limit, so it can do 125 amps. And if we come back here and see what the actual max current was, it was about 65 amps. So the batteries had some reserve. It could nearly go to twice that amount of power if they had to handle any spikes in power. And the last one, which I won't dwell on, is the actual GPS location. And you can actually get the run off the download off the GPS and get the actual street run that you actually did. We won't show that for privacy reasons. So overall, this particular machine, which is Ford Transit van, ran for 8 hours quite comfortably. I have to say, how good's that?